Imagine you could design complex aerospace brackets, optimized heat exchangers, or lightweight automotive components, all without ever touching a CAD software. Instead, you just type a sentence. Create a titanium bracket with a honeycomb lattice that minimizes weight but supports 200 newtons of force. And in seconds, a 3D printable CAD model appears, ready for analysis and production. That is the reality we are heading toward with text-to-CAD technology and AI-driven generative design. Welcome to Inside Metal Additive Manufacturing, the podcast. We explore the cutting edge of additive manufacturing, AI, and digital design. Today, we're diving deep into one of the most exciting developments in AM, text-to-CAD, and how generative AI is reshaping the way we design for 3D printing, particularly in metal AM and aerospace engineering. We'll break this down into a few key areas. First, we'll talk about what text-to-CAD is and how it works. Then, we'll explore the key players developing this technology and where it's being adopted today. We'll look at open source versus proprietary solutions and, most importantly, how this AI-powered design approach could transform industries like aerospace and high-performance manufacturing. Plus, I'll walk you through a real-world case study that shows how companies are already putting this to work. So, whether you're an engineer, a researcher, or a business leader exploring AI's role in AM, this episode is for you. Let's start with the basics. What exactly is text-to-CAD? At its core, text-to-CAD is an AI-driven process that allows engineers to generate 3D CAD models using natural language inputs. Instead of manually drawing up a design in software like SolidWorks or Fusion 360, engineers can describe a part in plain English, or any language really, and AI interprets that input, generating a parametric CAD model in formats like STEP, IGES, or STL. This is different from traditional text-to-3D AI, which often produces mesh-based models that are difficult to modify. Text-to-CAD focuses on engineering-grade, fully editable CAD files that integrate directly into digital manufacturing workflows. Think of it as having an AI-powered assistant that understands mechanical design principles, manufacturability constraints, and best practices for additive manufacturing. How does it work? Well, these AI models are trained on massive datasets of CAD geometries, engineering drawings, and even simulation data. They use natural language processing to interpret the user's intent and then apply computational design principles to generate a solid model. The AI doesn't just guess, it follows predefined rules and optimization techniques, which makes it especially useful for generative design and AM. So, who's leading the way in this space? Right now, we have a mix of startups, established AM companies, and big tech firms working on text-to-CAD solutions. One of the most talked about players is Zoo, formerly known as KittyCAD. They've built an open-source text-to-CAD tool that allows users to generate simple mechanical parts, like gears, brackets, and impellers, through natural language prompts. Their founders come from aerospace backgrounds, and they're positioning their technology for serious engineering applications. Then there's Backflip AI, a startup founded by Greg Mark of Markforged. Backflip has raised $30 million to develop AI tools that generate ready-to-print CAD models for industrial applications. They're focused on automating part design for spare parts and rapid prototyping, a use case that could drastically reduce downtime in factories and supply chains. Even big companies like Autodesk and NVIDIA are entering the game. Autodesk's Project Bernini is an experimental AI-driven CAD generator that aims to integrate with Fusion 360. Meanwhile, NVIDIA has been working on generative AI tools that can automate complex engineering tasks, including lattice design and topology optimization. Who's using this technology right now? The earliest adopters are in aerospace, automotive, and industrial machinery, industries that demand lightweight, high performance, and custom-designed components. AM service bureaus and rapid prototyping firms are also testing these tools to see how much they can accelerate product development cycles. Now, let's talk about the different approaches in this space. Open source versus proprietary AI solutions. On one hand, we have open source tools like Zoo's Text-to-CAD, which give engineers and developers access to the technology without locking them into a specific software ecosystem. Open source projects are great for transparency, community-driven innovation, and customization. However, they can also be less polished and may require significant expertise to implement at scale. On the other hand, proprietary AI-powered CAD systems like Backflip's software and Autodesk's upcoming tools are designed for seamless enterprise integration. These platforms often come with pre-trained AI models, built-in manufacturing constraints, and direct compatibility with major CAD and AM software. The trade-off? These systems can be expensive, and users might be locked into a vendor's ecosystem. At the end of the day, both approaches will coexist. Open source platforms will democratize access to AI-driven CAD, while enterprise solutions will bring professional-grade reliability to industries like aerospace and defense. Let's look at a real-world case where text-to-CAD is already proving its value. One of the most compelling examples comes from a user who leveraged Zoo's text-to-CAD tool to design a functional gear assembly. Instead of manually modeling each gear, the user described their specifications in text, and the AI generated dimensionally accurate CAD models. These parts were then 3D printed and successfully assembled, demonstrating how AI can speed up mechanical design. Another use case involves spare part replacement in manufacturing. Imagine a factory with an outdated machine that needs a custom bracket replaced. Instead of reverse engineering it manually, an engineer could type, "Generate a steel mounting bracket with 4 bolt holes, optimized for a 200-pound load." The AI produces a model in minutes, which can be printed in metal and installed the same day. Companies like Backflip are building AI systems specifically to support this kind of workflow. So, what does all this mean for metal additive manufacturing and aerospace engineering? For metal AM, Text-to-CAD represents a game changer for design optimization. Engineers will be able to create complex, lightweight structures in seconds, reducing reliance on time-consuming CAD modeling. AI can generate lattice structures, organic geometries, and topology-optimized parts that are tailor-made for additive processes. In aerospace, where every gram counts, AI-assisted CAD could lead to the next generation of ultra-light, high-strength components. Think of AI-driven cooling channels in rocket engines, weight-saving brackets for aircraft, or optimized fuel nozzles. Text-to-CAD will enable engineers to explore these innovations at unprecedented speeds. Text-to-CAD is still in its early days, but its potential is undeniable. As AI improves, we're looking at a future where engineers work alongside AI, not against it, using these tools to enhance creativity, efficiency, and manufacturability. If you're in the AM industry, now is the time to start exploring AI-driven CAD tools. Experiment with open-source platforms. Follow developments from companies like Backflip and Autodesk, and think about how generative design can fit into your workflows. That's it for today's episode. Thanks for tuning in. Be sure to subscribe and leave a review, and I'll see you next time as we explore the future of AI in additive engineering. Sa piropo.